And that's actually what we see. A lot of batteries that are most effective at abating carbon are in areas where there is quite a bit of congestion and renewable power being bottlenecked behind transmission constraints. Carbon is very hard to measure accurately, and account for accurately, and there's a lot of people working on that problem. And so in our case, the kind of nice thing about power markets is that, a battery's charge and discharge can be measured via a revenue grade meter on the power grid. There's pretty much no ambiguity about what a battery is doing. And it's all kind of this data science problem of wrangling all the data coming off of the battery and then inputting into a software solution that can measure the impact and essentially translate that charge and discharge activity into a quantified tons of abated carbon. Effectively calculate is the carbon content of the power when the battery is charging, and then we can calculate the carbon content of the power when the battery is discharging, effectively what it's displacing. And that delta you can think of as kind of a carbon arbitrage.
Hello and welcome back to Transmission. Battery energy storage systems in Great Britain are on track to save 1.4 million tonnes of CO2 in 2024. Batteries save carbon emissions directly through their energy actions by importing low-carbon energy and exporting it when demand is high, as well as frequency response services and inertia management saving. In today's Modo Selects, we're revisiting an episode from February with Emma Konet, co-founder and CTO of Tierra Climate. Over the episode, Emma explains the role of batteries as carbon offset tools and how changing their energy actions, combined with things like better carbon accounting, can help identify how and where batteries can make the most impact and what can be done to incentivize emission-reducing behaviour. Modo Energy's recent article, Carbon Emissions Reduced by Batteries in Great Britain, explores the total carbon saved by batteries in GB since 2021 and where these savings come from. Tiara Climate have published multiple white papers on the economic and environmental performance of the ERCOT BESS fleet. Their most recent, titled Supercharging Battery Economics, Shrinking Emissions, is available via their website. Both articles are linked in the show notes. If you're enjoying the podcast, please hit subscribe so you never miss an episode, and give us a rating wherever you listen. Let's jump in.
Hello, Emma.
Hi, Q.
Welcome to the podcast. Thanks for coming on.
Thank you so much for having me.
We'll jump straight in. Emma, how are we talking and who are you and what do you do?
Sure. Yeah, my name is Emma Konet. I'm co-founder and CTO of Tierra Climate, which is a clean tech startup that is looking to help grid-scale batteries monetize their environmental impact through carbon offsets. And we also provide software services, optimization services to support those carbon offtake contracts.
And what we're going to talk about today is quite unusual. The way that you guys are flipping the way that we think and look at carbon and accounting for carbon and how it really matters for flexible assets is, we're going to jump down that rabbit hole in a second. But I guess to warm the audience up, if you've listened to our podcast before talking about carbon certificates and accounting and matching and all those things, what we're going to talk about today is going to be a little bit different. And I think hopefully where we're going to get to is that there is a different way of looking at this problem, which means that the whole system gets a lot more value and flexible assets get more value too. But Emma, if you could just start at the beginning, what's going on with carbon in general and carbon accounting, and what's the problem that we're talking about here from the top?
Sure. Yeah, I think, carbon offsets are a way for a company to reduce their emissions. Most of the time they're used to offset scope 3 emissions that are really hard to decarbonize internally. So that's like supply chain emissions are really hard to get to net zero through internal action. So a lot of companies will rely on carbon offsets to reduce their carbon footprint to reach their net zero goals or whatever their climate goals might be. And we kind of think about carbon offsets on these two axes. There are avoidance offsets and removal offsets. And then there are nature-based solutions and engineered solutions. And carbon offsets can kind of fall in any quadrant along those two axes. And what we've kind of seen in recent years is the market move a little bit away from nature-based offsets that are typically avoidance in nature. So that would be a project like avoided deforestation in a developing country.
Before we jump in there, can we just talk about those four quadrants in more detail for a second? Because I know it's second nature to you, but...
Sure.
So we've got a matrix here, and it's a 2x2. And what's each one in detail?
Yeah. So avoidance offsets are where someone is paying an emitter to stop emitting. And a removal offset is basically when you take carbon out of the atmosphere and store it. So that could be like a carbon capture project, mineralization, any type of project that actually takes CO2 and stores it permanently. And then when we think about engineered versus nature-based, nature-based is like, as you could guess, a lot of tree planting, forestry projects, things of that nature. And then engineered solutions could be something like an energy storage project or, a carbon capture and sequestration project, something that we physically engineer to do the carbon removal activity or in some cases like ours, an avoidance activity.
And are these pieces of paper that are moving around, or are these, what is there a centralized systems? Is this government? Is it what? Who sets the rules of this whole thing?
Yeah, there's a couple different flavors. We play primarily in the voluntary carbon market, and there are several nonprofit registries that basically register a carbon offset project and then verify that those offsets are legitimate. And there's a lot of reporting and verification and, for like a soil carbon project, there's, measurement of carbon content in soil to verify that all these credits are what, they say you're getting what you think you're buying. The problem is that, these nature-based offsets have been under fire in recent months for not being accurate. And I think that's what's really pushed the market towards more kind of engineered solutions that have a high degree of empirical evidence that what you're paying for is exactly what you're getting.
Okay, and so I stopped you midway through your bit there to talk about the quadrants. So on the engineered, so let's do those two, engineered and nature based. Could you give some more examples of what types of things those are, and then we'll talk a little bit more.
Sure. So a nature-based solution could be like, maybe you see some companies that say, hey, we offset all of our emissions by planting trees. And so they're paying someone somewhere to go plant trees in the hope that that will become a carbon sink. And depending on how the project is set up, sometimes those carbon savings are realized like over the life of the carbon project, actually when that tree is planted. And so to some degree, that's kind of why there's pushback against nature-based offsets, because that carbon doesn't realize obviously on the day the seed is planted, it realizes over the life of that tree growing. And there's a lot of things that can happen to a tree. Is it going to get cut down? Is it going to burn down? And so I think that that's some of the criticisms of like a forestry project. And then on the flip side, you have these engineered solutions, and there's kind of the classic, pulling gas out of the air and storing it underground and having monitoring facilities to make sure that there's no leakage and that it's permanent storage of carbon. But there's also engineered solutions like energy storage projects, and energy storage or grid scale batteries actually falls into this unique quadrant that we don't really see a lot of, which is that it is an avoidance offset, but it's also an engineered solution. And we don't see a lot of engineered avoidance offsets. And I think that's what makes what we're working on unique. And basically, the avoided emissions that an energy storage project accomplishes is avoided combustion of fossil fuels for electricity generation. So effectively, instead of relying on fossil fuels to ramp up to meet demand when renewable energy is not being produced, we can actually store renewable energy and then deliver it to the grid when it's needed to displace fossil fuels. And so it's avoided carbon emissions.
And this is awesome because for those of us who've been doing stuff in the battery space for a few years, we've all sort of known, you can sort of figure it out that batteries displacing fossil fuels on at peak times and removing, gas units or coal units, and then preventing curtailment of wind and solar. This is all good stuff, right? We know it's all good stuff, but then accounting for it, I don't feel like anyone's really made that leap yet. And I guess that's where you guys come in.
Yeah, exactly. I mean, this is something that I kind of wondered about. So my background is I worked at a energy storage developer, owner, operator, and I was in charge of operations. So I wrote all the software that does the dispatch. And occasionally I would be supporting like an RFP where the question would be like, what's the environmental impact of this asset? And I think everyone, like you said, sort of intuitively you think, okay, you soak up the extra renewables, you displace the fossil fuels. That's kind of the classic energy arbitrage use case of a battery. And I think a lot of people just think, okay, so it must have an environmental benefit, but no one, I mean, it's very hard to quantify. And I started to think, okay, how do we quantify what the actual environmental benefit is? And we ended up, my co-founder and I ended up partnering with a company called Resurety that produces a data set called a locational marginal emissions factor. And effectively, for your listeners who are familiar with kind of how electricity pricing works, it's very similar to a locational marginal price, except for instead of representing the marginal price of the next unit providing, supplying demand, it's the emissions of that unit, the emissions in basically carbon per megawatt hour. And so what we
Awesome.
can effectively calculate is the carbon content of the power when the battery is charging. And then we can calculate the carbon content of the power when the battery is discharging, effectively what it's displacing. And that delta you can think of as kind of a carbon arbitrage. And so that's how we can actually measure
Like
how
arbitrage.
a carbitrage, if you will. That's great. I love it. Yeah, so that's how we're able to quantify the impact. And it's certainly an impact that batteries are having right now that they're not being compensated for. So I think it's really important that we recognize batteries and just grid scale storage in general for that benefit to the grid.
So let's talk about Tierra for a second. What's the background there? Well, we didn't really talk about you. You said you worked for a big developer. Let's jump into that. What were you doing before this? How did you get the idea? How long has the company been going? Who's involved? And what's the big vision?
Sure. Yeah, so I started off my career as a power trader at Citi, and I was trading US power markets, and I stayed there for 4 years. That's actually where I met my co-founder. We were on adjacent power trading desks, and then he went to the origination side and did a bunch of deals with wind and solar projects. And after 4 years at the bank, I decided I was pretty interested in what I thought was going to be a big change in power markets with energy storage coming to the market and really being built out at scale. So I joined an energy storage developer, owner, and operator called Key Capture Energy. It's a US based company, actually based out of New York. I live in Houston, so I was working out of the Houston office. And I worked there for a little over 3 years. And how Tiara Climate was born was really out of problems that I was seeing in the industry working with storage. And I've seen some of the Modo headlines that are kind of reflecting this same thing in the UK, which is that the revenues can sometimes be a little bit dire, and there's sort of this cannibalization of ancillary service markets that's kind of impending. Not all markets really pencil. Like there's a lot of markets where like we clearly need a lot of energy storage, but sometimes it's difficult to make the financial case to actually go build it. And then on top of that, there's this kind of like unquantifiable environmental benefit that makes it a little bit difficult to get offtake from, a corporate buyer that maybe does it's easy for a corporate buyer to like see the value of like a wind farm, like doing a deal with a wind farm or solar farm because they know, oh, you produce renewable power, great. It's kind of a classic just generation asset. Whereas like energy storage is a net load on the system. So there's a lot of questions about how you value it. What is the environmental benefit? How do we get offtake to be able to make cash flows more stabilized and build more of these assets? So all of that led me to Tierra Climate, where we've been working on it since January 2023, and I went full time on it in April of 2023 with my co-founder. And yeah, we've had a lot of progress since then. I think we'd like to think we've become sort of thought leaders in the space. We wrote a white paper, studying the ERCOT power grid and all the batteries in operations in 2022. And we're now leading the Energy Storage Solutions Consortium, which is a group of folks in the industry ranging from developers, owner-operators, corporates who are looking to do deals, service providers, to stand up a methodology with Verra for energy storage. And our goal as a company and really the grand vision is to create a market where, kind of akin to the rec market for wind and solar, where batteries can monetize their environmental impact and corporates can start doing deals with energy storage without having to take on, like a full toll or like kind of a massive operational liability. And support energy storage through software and contracts kind of through the life of the next, I would say, probably 100 years of the power grid, where we're going to move from the fossil fuel age to the age of renewables and batteries.
I love it. Absolutely love it. What we've got to do here is turn something very intangible into something tangible. And that's going to involve some maths. So I want to talk about how you guys do the maths and what you're thinking about that. But yeah, it's great because for 10 years, there's been this feel-good factor of we know we're doing something right here. But it's, to have someone do the maths on it and prove out the value beyond just revenues, I think will be really interesting. So can we talk about that for a second? Your role in Tierra Climate, I can imagine it's a tricky role if you're going to be doing the accounting on this stuff, because you will hit skepticism left, right, and center, I imagine. And you have to be incredibly rigorous, transparent, and a tricky role in the middle of a market. So how are you thinking about building a company that will do that? And then can we jump into the detail about how you're thinking about accounting for this stuff? There's lots of inputs and outputs and inefficiencies and whatever. And what we really need is for this to work for all of us in the market, it's got to be really robust. So how are you thinking about those things?
Yeah, well, I guess the benefit of going through a carbon registry like Farah is that it's not just Tierra Climate that's sitting there and saying, hey, we want to stand up this new product. This is how we're going to measure it. There's actually like an independent body that they're called VVBs that come and verify the VVBs.
VBBs. What does
Yeah.
that stand for?
Oh
VUBs.
gosh. Verification. Hold on. Sorry. I always forget this acronym. VVB, Validation and Verification Body.
Okay.
Validation and Verification Body.
They sound incredibly scary. Yeah.
VVB. And so essentially what they do is that once you have a methodology stood up with Verra and you have a carbon project that's registered with Verra, you have to continually...
Who's Verra, Emma? Sorry, for those who don't know.
Sure. So Verra is a nonprofit carbon registry. And so they basically evaluate, they're called carbon methodologies, which is basically like someone comes and says, hey, there's some technology or some project that we know can cause carbon reductions. And we want to get that project recognized for those carbon reductions. And we want to generate a credit that is like a Verra-backed credit. And there's other registries that do this as well. Verra is just one of the world's largest. And so, yeah, so Verra approves the methodology and says, okay, this is like a legitimate way to generate carbon offsets. You can register projects under this umbrella methodology, but that's not enough to start generating credits for the life of the project. And crediting period is usually 10 years. So what happens is you register a project and then it has to be validated and verified by the VVB. And so for every crediting period, I think they're typically a year, like it's a 10-year crediting period to register an asset, but then the credits get validated every year. You actually have to have this VVB come in and look at all your data. And in some cases, if it's like a nature-based project, go actually take soil measurements. So they fly people out to the project and they validate that sensors are working properly. And they do a lot of statistics around expected error bars, and they have discount factors associated with those error bars. So it's I would say a genuine attempt to. Carbon is very hard to measure accurately, and account for accurately, and there's a lot of people working on that problem. And carbon registries make a really genuine attempt to get as accurate as possible account for how much carbon is being reduced. And so in our case, the kind of nice thing about power markets is that, a battery's charge and discharge can be measured via a revenue grade meter on the power grid. There's pretty much no ambiguity about what a battery is doing. And it's all kind of this data science problem of wrangling all the data coming off of the battery and then inputting into a software solution that can measure the impact and essentially translate that charge and discharge activity into a quantified tons of abated carbon. And I think the second part of your question was basically like, how do we kind of baseline that, or how do we think about what we call as the counterfactual in carbon markets? It's supposed to represent what would have happened absent a carbon market, right? And there's this concept of additionality in carbon markets, whereby a carbon credit has to represent carbon reductions above and beyond the normal course of business activity. So it's not enough to just say, well, sure, a battery can reduce carbon, but if the carbon market isn't responsible for getting that battery built, then that's not an additional removal. It's kind of an oxymoron, but additionality.
I'm with you.
Okay. So there's kind of two flavors of how we think about this. The first is that batteries don't necessarily inherently reduce carbon depending on which market they're operating in, their operating mode, their location on the grid. They do the thing that maximizes the revenue. And oftentimes that's providing ancillary services to the grid. And so if you give a battery a carbon signal, like say, hey, I'm willing to pay you, $50 a ton for every ton of carbon you abate, they can actually change their behavior from kind of that baseline that may be emissive, or it may just be that they're not reaching their full abatement potential. and shift their behavior to now be a more carbon abating asset. And that delta between like what they would do in a revenue maximizing approach versus what they would do under a carbon market construct is how we account for like the additionality of these offsets in an energy storage construct. So that's kind of one option. The other option is that there, like I mentioned earlier, there's markets where batteries don't make financial sense, or in certain like applications, like if there's an existing solar project and someone wants to add a battery but they're having trouble making the financial case, it's possible that the carbon market could step in and kind of fill that gap, that kind of missing money problem that gets a battery from NPV negative to NPV positive. And in that case, the carbon market is responsible for getting that battery built. And so that would, we would consider that to be like full additionality. And so that every ton that battery abates is an additional ton that we can credit through a carbon market.
It's a completely different way of thinking, right? So for basically since day zero of this industry, we've been trying to make the IRRs as high as possible on a purely financial basis to get investment moving, to get these assets built. And what really excites me about this is if you think about, Microsoft or Google or these big data center providers who have committed to net zero over the long term, some of them very ambitiously, it's very easy for them to say, oh, I know what we'll do. I say very easy. These are complex things to do, but it's simpler to say, I tell you what, we're going to take PPAs from wind farms. And there may be a more attractive way of getting to net zero for them via energy storage that until now wasn't really possible to quantify in a tangible way. It's really, really exciting. Can we just talk about some of the complexities of calculating this stuff for a second? Because you'd think, so I get the ancillary services bit, which is for assets to be, say you're sat in ancillary services contracts and you're only using 10, 20% of your total power for most of the time. You actually got an asset that isn't fully utilized there, full stop. So that in itself is an inefficiency in the system, which will probably turn up in the carbon accounting somewhere. But you'd think that if you were doing, and excuse the clumsiness of this phrase, but arbitrage, right? And I know that really rattles some people to talk about it. But if you are buying cheap, selling high, looking to sell on peaks where there's more scarcity of generation, you'd think that those periods would be the high carbon periods anyway, because cost and carbon should be correlated. But that's not always the case. So there's a natural way that I think separate to ancillary services, that batteries, if they just follow price, they'll probably follow a pretty good proxy for carbon, even if it's not perfect. What have you found I know you've done a lot of analysis on this and you've written your white paper and there's loads of work happening in this. What are your thoughts on battery operations and where they can add most value from a carbon perspective?
Sure. So I've studied this pretty in depth in the Texas market in ERCOT, which has a pretty substantial penetration of renewable energy. So I think it's a nice case study, and it also doesn't have a capacity market. So it's kind of a nice case study to see what, a free market, power market should incentivize a battery to do in a high renewable penetration kind of construct. And what we found actually is that, we looked at all the batteries operating in 2022 is about, I think it was like 24 batteries. Well, only 19 of them, or only 5 of them actually reduce emissions. The rest of them caused emissions to go up. And it's
wow.
I know, it's a
wow.
little sad. I know, it's a little stark. But the good news is a lot of them have the capability to reduce emissions. Many of them do. In fact, yeah, many of them can reduce emissions at a not so unreasonable price of carbon. Basically between $50 and $100 a ton, which sounds high for folks who are familiar with like the voluntary carbon market and avoidance offsets specifically. But I think that there is appetite to pay in that.
To Europeans, it's just to Europeans, it sounds totally reasonable. We have a carbon market, and that sounds about right, But I get to American folks, that sounds absolutely bizarre.
Yeah. So what we found about with respect to the correlation between energy prices and emissions factors is actually, and I'm with you, I completely expected this to be quite high. Like I was expecting like a 0.8, 0.9 correlation, just because naturally you expect that the more expensive units are burning fuel and they should have a higher LME. Well, it's actually about 0.2. So it's a lot lower than you would expect. So just purely, and that's for a variety of reasons.
It's like you've told me that Santa Claus isn't real.
Okay, this will make you feel better. As we get more renewable penetration in the market, that correlation will go up significantly. Because the reason why it's so low is because it's not high in the thermal stack, meaning that basically if the marginal producer is somewhere like gas, coal, fuel oil, somewhere in the thermal stack, there's a lot of things that can cause, there's like fuel prices, like coal to gas switching. Depends on global LNG demand and like natural gas, like geopolitics. There's a lot of things that can like impact the price of fuel, which impacts the marginal generator's price depending on the fuel type. And so the correlation kind of breaks down on the thermostat. But as the thermostat runs less because we're increasingly adding renewable energy, we tend to see that correlation improve because wind and solar projects have a zero emissions. They're clean power, right? So if you actually take the thermal stack completely out and you really just look at like the very high end, like we're talking emissions factors like zero point 0.6 tons per megawatt hour, and then you also just look at the low end, like the zero emissions per megawatt hour, then the correlation improves to like 0.5, 0.6. But it's still not, I mean, it's still not one. So the
Still
problem
not
there
one.
is,
Yeah.
yeah, the problem there is like if you just operate to do energy arbitrage purely to real-time energy prices, you're not guaranteed to maximize the carbon abatement potential of your asset. You actually have to forecast emissions factors and put that in your optimization engine. And if there's a value of carbon, then that has a value of revenue. It's a revenue stream to the operator, right? So they can just, depending on the relative value of energy price versus carbon price, the asset should, you know, participate in markets one way or another. And if like the energy price goes bananas, and is kind of hitting price cap, then the carbon value is going to be very de minimis. And so the battery would just purely respond basically to the energy signal. But on like an average day where power is maybe like $20 or $30, the battery will respond to that carbon market. And effectively what we see is them cycle more and cycle in hours that have a higher probability of displacing a fossil fuel unit and charging from renewable energy.
So now we're talking real-time forecasting of carbon emissions as a signal, as an input to an optimization engine. What about
Right.
what about congestion? So what about when batteries are being used to manage congestion on the network? That feels like a more complicated problem where there may be non-obvious sort of second-order carbon benefits or carbon problem getting worse, as we've just discussed. How are you guys thinking about that problem? Wow, this is such a complicated topic. There is so much to talk about here.
I
How are you thinking about that?
So the nice thing about locational marginal emissions factors is that they account for the impact of congestion. And that's actually what we see. A lot of batteries that are most effective at abating carbon are in areas where there is quite a bit of congestion and renewable power being bottlenecked behind transmission constraints. So, effectively what an LME represents is the locational marginal, emissions. So if the power cannot flow because there's a transmission constraint that's preventing the renewable generation from meeting the load, then that marginal generator in that place is a renewable facility and the LME is zero. So this is where we find projects that are located in like renewable pockets where price is frequently going to zero or negative in some cases in US markets. Then a battery is able to like kind of soak up that power at a super low price and a low LME, and then store it. And then when the transmission constraint is relieved because of demand is reduced, probably most of the reason why we see that kind of diurnal shift, then a battery is able to just displace fossil fuels by discharging across that transmission line. And that's basically because the renewables are no longer producing at that time.
Yeah, I mean, it could even go there's like a double negative here. And that if say you're in West Texas and it's, there's a lot of wind and it's the middle of the day. And so we've got curtailment and your battery is preventing curtailment and then using it up later. You kind of have like a double benefit there,
Yeah.
which is nice.
So we think of this is kind of raising an interesting point. So we think of like decarbonizing power as two discrete actions. The first action is that a renewable megawatt hour has to be produced. And that's typically captured, like there's the instrument that monetizes that action is like a renewable energy credit. The second action is that you have to take that energy and displace a fossil fuel generator. So sometimes those two actions happen together with a renewable facility because a renewable project is generating at the same time they're able to displace fossil fuels, so everyone's happy. But increasingly, and as the grid becomes more saturated with renewables, that first action is happening, but the second isn't because it's a time-based issue. So you could have renewables producing, and this is classic like duck curve, like if when solar is producing in California in like the middle of the day, and it's like all the load in a certain area or sometimes on the grid is being served by renewables, then one incremental megawatt hour of solar power doesn't have any decarbonization effect, because when the sun goes down, we're still going to have to ramp up fossil fuels to meet demand. So what we're kind of trying to think about is separating those two things so that when that happens, when the production of the megawatt hour does not align with the displacement of a fossil fuel generator, the REC just recognizes the production, and the carbon credit recognizes the value of shifting that production to a high carbon intensity period. And so those are kind of the two I think it's a different way of framing the thinking, because I think the classic, for the last 20 years, a classic example has just been you produce a renewable megawatt hour and you're greening the grid. And that's not always the case anymore. It's just kind of this new age that we're entering into, where a combination of high renewable penetration and congestion is causing curtailment, like you mentioned. And so the battery can soak up the power and basically enable more production. By charging, it's enabling more production of those renewable megawatt hours.
So just to steelman the argument then. So what's wrong with just megawatt matching? So megawatt matching, well, let's talk, what is that? And this is kind of what we've been doing for a long time now. It kind of makes sense. You can talk about it in the bar and everyone understands it. You make a megawatt, you match it with a thing. How does that work right now? And what's the problem with it?
Yeah, I don't actually think there's necessarily a problem with it. I think it's a different way of thinking about the problem, and it's in pursuit of achieving the same goal, which is to get to a net zero grid. So effectively, there's two camps. There's a megawatt hour matching, which is sometimes called a 24/7 carbon free energy construct, or CFE, and then there's this emissions first approach. And the difference between the two is that in megawatt hour matching, you're effectively trying to take a discrete load. So like if I'm a company, if I'm Microsoft and I have my data center load, and I know what that load profile is, and it's probably pretty flat because it's a data center, then I just need to make sure that I'm buying renewable energy from somewhere and every hour that I have load to exactly meet the megawatt requirement that I have my load. And there's some constraints around where that power has to be located, same grid. It's supposed to be as close as possible to the load, because effectively what 24/7 megawatt hour matching ignores is congestion. So if there is congestion between where you're buying your power and where your load is, now all of a sudden it's pretty difficult to claim that renewable energy is actually serving your load. Where I think the 24/7 contracts is actually really impactful is that because it requires such a strict matching, it basically requires you to over procure renewables and storage. And so that over procurement has a net positive effect on the grid. That's kind of like a social good. The kind of emissions first framework, which is where Tierra Climate is slotting in with our carbon offset, is basically, it says like figure out what your carbon footprint is through like robust and accurate carbon accounting, like a locational marginal emissions approach. And this is kind of mostly focusing on scope 2, but figure out what your impact is, and then figure out the most cost effective way to get that impact down to zero. And so you basically solve for the tons first, and then you do net reduction projects. That could be like an inset, it could be an offset, it could be a variety of things to get that carbon footprint down to zero. And so I don't necessarily think, the communities behind each of these kind of ideas, the emissions first and the 24/7, seem to be a little bit at odds with each other, which I don't think should be the case. I think that there are very clear ways in which they can work together. We need to like not have infighting amongst ourselves in like kind of the clean energy transition movement, because I think it just erodes the momentum. And instead, I think we should think of it as like both constructs moving us towards the same goal and just accomplishing it in different ways. The benefit I do think I see in the emissions first approach is that I think it's more attainable. I think it's like you don't have to have a trading desk, like an energy trading desk, in order to support like an emissions first approach, right? Versus like a 24/7, you have to have pretty sophisticated energy folks on staff that are managing your contracts and doing, optimization of energy storage. And it just gets really complicated. And the emissions first approach is, I also think, more affordable, because you don't have to necessarily over procure as much, because you're just trying to net out. Like you could, for example, enter into contracts for renewable facilities or batteries in really dirty grids. And that might not be where your load is, but the net impact of like building a wind farm in like a grid that's served mostly by coal is much more carbon impactful than building a wind farm in a grid that's mostly served by wind, right? So that's kind of the difference. And I think that's where we've seen a lot of momentum behind the emissions first approach.
You can also apply it to things beyond batteries, right? I'm just thinking there's loads of asset classes you could apply this to beyond just energy storage. You can, for large loads, for Bitcoin miners, even some transmission equipment. There's all sorts you could do. I love my job on this podcast because I get to have these kind of conversations all the time. This is absolutely fascinating. Emma, we've got two more questions to ask you. The first one is, what do you want to shout about? What do you want everybody to hear about? What you're working on, and what do you want to plug?
Sure. So right now we're working on a tool that will help developers and owner operators of batteries understand what their carbon impact is of either an existing asset or an asset that's in development that they hope to build that doesn't exist yet. And that will really help developers understand which of the projects in their portfolio are the best candidate for a deal like this, that have the most capability of abating carbon, and also what price they need. Like what carbon price do you need? Because it's not the same at every asset necessarily, right? Like what a battery needs to pencil in one market based on its operating mode and the LME at its node is not the same, as another project that's, operating in a completely different way. So this tool is designed to help really, illuminate this kind of question that I feel like has been sort of shrouded in mystery for a long time. What's the environmental impact, and what's the value associated with carbon abatement at that asset? And then for developers or for corporate off-takers, it can serve the same function. They could say, okay, if I went into a contract at a battery at this node, or I'm approached to do a deal at this site, how can I understand what the value is of that deal? And how can I understand how much carbon I expect to be able to buy off of this project on a yearly basis? How much variance is there around that? So that's what we're working on right now, and we're rolling that out in the next couple weeks to some beta testers. And
Awesome.
yeah, we're really excited to get feedback on that and continue to build that out. And we kind of, our grand vision is to eventually have forecasting, like long run forecasting over 10, 20 years, to be able to understand what this looks like over the life of the project under different scenarios, different weather scenarios, different assumptions around wind and solar penetration, gas price, stuff like that. So that's kind of the first thing. And then the second thing I'll say is that I don't think it's enough to just stand up a carbon offset, because a carbon offset can exist, and like you can buy it and apply it against your scope 3. And I think that's probably an initial phase of this product, what is going to happen. But eventually we need to be able to account for carbon offsets in scope 2 from batteries, because when we do our scope 2 accounting right now, the only product you can, like market-based product you can use, is a REC. And we know that batteries don't generate RECs. So the greenhouse gas protocols, scope 2 guidance, or the whole protocols, is under review right now for a major overhaul. And there's going to be changes made to the scope 2 guidance. And these are the protocols that most companies use to report their scope 2 emissions. So I think it's imperative that we pay attention to what's going on so that we can include energy storage in how clean energy is recognized and attributed and reported in, SEC filings, ESG reporting, all those things, so that it's kind of embedded in the standard. Like we don't want storage to get left behind. These protocols are revised like every 10 years. It is like go time to make sure that storage is included in the discussion right now.
And finally, everybody's favorite question. So what's your contrarian view?
Sure. So my contrarian view, and to some people, this is not contrarian at all, but to some people it is. So I guess maybe that's what makes it, controversial. But yeah, it's that batteries are not inherently carbon reducing assets. And like when you talk to some developers, I think that some people think if we stand up and we say this out loud, it's just going to fuel the narrative that we should just keep relying on oil and gas, because if batteries increase emissions, then why are we building them? That's like the fear that if we state the facts around what batteries are doing, that there's going to be backlash and it's going to like stall momentum for the industry. And that's absolutely what we do not want that to happen. Like we want to build more batteries. We need more batteries. It is very clear to anyone who can logic out what batteries are used for that they have an immense carbon abatement potential. But I think it's worth recognizing that it's not enough to just procure these assets, that if we want them to do the activity that we hope for, which is carbon abatement, we actually have to tell them to do it. Like you have to guide the operations. And, what solves this problem completely is a carbon tax, because then the value of carbon is embedded into power markets inherently, right? It's embedded into the bids and offers of fossil fuel generators. Power prices rise up. Like SCED now, like, the system that dispatches the grid basically just accounts for that value. We don't have a carbon tax in the US. It's very hard to see a world in which we get one in the next 10 years. And so this product, this carbon offset product, or really just a carbon signal in general, I mean, the 24/7 is kind of has a carbon signal embedded in it, can function to influence a battery to take the activity, to do more of the activity that we're actually aiming for when we build batteries. And of course, batteries have a ton of other benefits. I don't mean, grid stability, ancillary services, like those are extremely important, and batteries are great at providing them. But we're not building, 400 gigawatts of batteries in the US to provide ancillary services, right? We're building them to firm load, or to firm up renewables to serve load. So that's, I guess, my contrarian view is, I'm sort of facing the fact, certainly not what I hoped to find when I started studying this. I was hoping to find that batteries were just these great carbon abating assets and we just need to pay them. And it's unfortunately not the case. I mean, some are, but most aren't. And, I think it's time for the industry to just recognize that, we have to do something about that. And perhaps, not to take this question super long, but perhaps it's one of those things that like naturally would get sorted out in 20 years. Like you said, like the correlation between LMEs and energy price is going to get higher as we add renewable energy to the grid. And so some people are like, well, maybe now they cause emissions to go up, but in 10 years, it shouldn't be a problem. And my response to that is like, we don't have 10 years. Like, we need to solve this problem right now. Like, we needed to solve this problem 5 years ago. And so
also, we've just got a measurement. I mean, any pushback on measurement is always shady, right? To some extent, there's always something in there. And so, yeah, let's measure it and let's improve it. I think actually that's a hell of a mic drop to finish what was an incredible conversation. Emma, I want to say a massive thank you for joining us on the podcast. It's been great. I'm looking forward to seeing you soon.
Thank you so much for having me, Q.
Thank you for listening to Transmission, a Modo Energy podcast. Transmission delivers conversations from industry leaders and experts exploring energy markets and the operations and technologies related to grid-scale battery energy storage. Check out our other episodes by searching Transmission wherever you get your podcasts. Check out the Energy Academy, our video crash course on how markets in Great Britain and ERCOT work, or head to modoenergy.com to see our written research. Thanks for listening.